Hello everyone. In this very video we are going to be looking at linear second order differential equations. Now by definition, the second order differential equation is an equation of the form d squared y over dx squared plus p dy dx plus qy equal to 0. Now or you have it this way. Now if this equation is equal to 0, we call it an homogeneous equation. But if it is equal to a function of x, we'll call it a non-homogeneous equation. Okay. Now the solution to a second order differential equation. Now the first thing is to transform the equation into a quadratic equation, either by using the operator form, that's one way, or by letting y to be exponential rx, that's another way. So if we have the homogeneous equation this way, now the operator form here, in this case, we are going to see dy dx, represent it as an operator, that means as d. So dy, so dy dx now is just d. So that means d over dx is represented by d. Okay, and if we do that, you can see that d squared y will be d squared, okay, because that's square, right? Then dy dx now will be d, and you have q. Okay, let's do that again. So you see that dy dx, now d over dx is d, so that is d dy. Then but d squared y over dx squared means we just squared this, that means it will be d squared y. Okay, so in the real sense, the whole of this is supposed to be d squared y plus p dy plus qy equal to 0. Now if you notice, y is common, so we can factorize y, and once we do that, we have something like this. Okay, so you see that the whole of this is rewritten thus: d squared plus pd plus q, all y equal to 0. Okay, and we can now write the characteristic quadratic equation as this. That means just replace d with r, and we have r squared plus pr plus q equal to 0. Now another way to achieve is by letting y to be equal to exponential rx. And of course, if y is exponential rx, the derivative of y with respect to x is r exponential rx. Don't forget that if y is equal to exponential ax, then it means that the y dx is going to be equal to a exponential ax. Okay, then the second derivative now is going to be r squared exponential rx. That's because the r here as the power multiplies r, to get this. Okay, so substituting it into our equation, remember, second order equation is still d squared y over dx squared plus p dy dx, okay, now plus q y, all equal to 0. Now if we substitute that, now you can see that the whole of this now is now r squared exponential rx, then p dy dx, your dy dx now is rp exponential rx, then your y is already exponential rx. Okay, so that's exactly what we get when we substitute these values into the differential equation. So we get this. Now you notice that exponential rx is common throughout, so if we factorize exponential rx, we are going to get this. Okay, by factorization is common here. This is exponential rx, this is exponential rx, this is exponential rx. When we factorize it, we are going to have r squared plus pr plus q equal to 0. So at this point here, we can now divide both sides by exponential rx. Okay, you can see this cancels this, and 0 over this is still 0, so we are still left with this. So you can see whichever way we choose to follow, we still arrive at this characteristic equation, which is r squared plus pr plus q equal to 0. Now we want to see the solution. Okay, we continue with the solution to first order equation. Remember, the characteristic quadratic equation has to be solved, and the roots of the solution to a quadratic equation are called the roots of the equation. So here we are seeing the roots of the equation to be r1 and r2. Okay, Now, these 3 points here gives us the solution, the general solution for a second order differential equation. If R1 is not equal to R2, that means if the roots are not equal, then it means that your general solution will be y equal to C1 exponential R1x plus C2 exponential R2x. Okay, now, but if R1 is equal to R2, that means if the roots are equal, okay? So it means that the general solution will be y equal to C1x plus C2 all exponential Rx, okay? There is a way you can still confirm that your answer is correct. Then if R1 is equal to A1, A plus IB, and R2 is A minus IB, that's complex root, okay? Now the first one there is real and distinct root. The second one there is talking about equal root, but the third one is talking about complex root. Then it means that our y will be equal to exponential ax, a cos bx plus ib cos. Sorry, that's a big mistake there. It should be a cos ax, okay? Then plus I b cos bx. So here should be b, your bx, okay? So let's go further to seeing questions. Now here we're asked to solve d squared y over dx squared plus dy dx minus 6y equal to 0. Now the first thing I'm supposed to do, okay, I want to use the operator form, meaning that I can represent this as d squared, then y, okay, then plus dy, okay, minus 6y equal to 0, right? So that means it's going to be d squared plus d minus 6 all into y is equal to 0. I believe that makes sense, which will return a characteristic equation of r squared plus r minus 6 equal to 0, which we can solve, okay? And solving this now quadratic equation, we look for two numbers that can multiply to give us minus 3, but when minus 6, but when they add, you get plus 1. And the numbers I can think about now is r plus 3 and r minus 2, okay? That's because 3 times minus 2 is minus 6 and 3 minus 2 is 1, okay? So from this, we can say that the solution to this characteristic equation, r1 is minus 3, then r2 is equal to 2, okay? So that's how we get our r1 is minus 3 and our r2 is equal to 2. Remember what we say our general solution to this equation is. We said it is equal to y equal to c1 exponential r1x now plus c2 exponential r2x, okay, such that if we substitute the values now, we are going to be getting c1 exponential, our r1 now is minus 3, so minus 3x, okay, plus c2, which is a constant, exponential, our r2 is 2, so you have 2x, which is the solution to that equation. So this is the final solution, that y equal to c1 exponential minus 3x plus c2 exponential 2x. Now there is a way we can show that this is correct. Let me use this opportunity to show us that. Now, how do I know that my answer is correct? Let's start again. We remember we got that y equal to c1 exponential r1x, that's 3x, okay, plus minus 3x, then plus c2 exponential 2x. Now I can find dy dx here, and my dy dx now, if I differentiate this now with respect to x, I'm going to get minus 3c1 exponential minus 3x, okay, plus this is going to give me 2c2 exponential 2x, okay. Then if I find the second derivative, which is d squared y over dx squared, it is going to give me minus 3 is going to give me 9c1 exponential minus 3x. Then y this is going to give us 4c2 exponential 2x, okay. So if we substitute this here in this equation, you can see that the squared y over the x squared is 9c1, okay, exponential minus 3x, okay, then plus 4c2 exponential 2x. Then dy dx, plus dy dx, that is minus 3c1 exponential minus 3x, okay, plus 2c2 exponential 2x, okay. Now minus 6 times y, so just subtract 6 times y, is going to be minus 6c1 exponential minus 3x, okay, then minus 6c2 exponential 2x, okay. So I want to believe you get that. Let me rub this off so that it can be a little clearer. So this is what we have. Now, if we now choose to add these three equations together, if you notice, the left hand side are the same thing, c1 exponential minus 3x. The right hand side is the same thing, c2 exponential 2x. So from here, 9 minus 3, you see, is 6, and 6 minus 6 is 0. The same thing here, 4 plus 2 is 6, 6 minus 6 is 0. You see, equal to 0. It satisfies this particular, differential equation. That makes our answer very correct. Okay, so we move to another question here. We are given the squared y over dx squared minus 9 dy dx plus 20y equal to 0. We asked to solve this. Now, using the operator form, it means I'll represent this as d squared minus 9d, okay, plus 20, all y equal to 0. You see that? So that means the characteristic equation now is going to be 9r squared minus 9r plus 20 equal to 0, which we can solve by, I think the two numbers that multiplies to give 20 but add to give 9 should be minus 4 and minus 5. So we have r minus 4, r minus 5 equal to 0. So you can see that my r1 here is 4 and my r2 here is 5. So meaning that the solution, general solution for this equation is going to be equal to c1 exponential 4x, okay, plus c2 exponential 5x. As the answer to the question. C1 exponential r1x, which is 4, and C2 exponential r2x, which is 5x. Okay, so let's see another question here. So we have 6 the squared y over the x squared plus 5 dy dx minus 6y equal to 0. If I should write the operator form here, this is going to be 6d squared, okay, plus 5d, okay, minus 6. All times y is common throughout, right, equal to 0. And the characteristic equation is going to be 6r squared plus 5r minus 6 is equal to 0, which you can solve by, I think we can use, this can be 6r squared plus 6r minus, that is going to be a mistake. So to solve this particular equation, we multiply the first and the last value, which is minus 36. So we look for two values that will multiply to give us minus 36, but when they add, it's going to give us 5. And from what I can see, 12 times 3, no, that's not going to work. 9 times 4 works very well. So it's going to give us 6r squared plus 9r minus 4r minus 6 equal to 0. Okay, here you see 3 is common. You're going to get 2r. Sorry, 3r is common here. We're going to get 2r plus 3. Then minus 2 is common here. You're going to get 2r plus 3, all equal to 0. Okay, so we now get 2r plus 3 and 3r minus 2 equal to 0. And with this, what does it mean? If 2r plus 3 is equal to 0, it means 2r is equal to minus 3. That means r is minus 3 over 2. The same thing here, if 3r minus 2 is equal to 0, 3r will be equal to 2. That means r is equal to 2 over 3. Okay, so with this, we can say, have our final answer. The general solution will be y equal to c1 exponential minus 3 over 2x, okay, then plus c2 exponential 2 over 3x. That is beautiful. That gives us the answer to that question. Now we see another one here. We have d squared y over dx squared minus 10 dy dx plus 25y equal to 0. The same thing, we have d squared, okay, minus 10d plus 25, okay, all into y is equal to 0. You see that? So the characteristic equation here is going to be r squared minus 10r plus 25 equal to 0. Now to solve this, now this is going to be r minus 5. R minus 5 is equal to 0. So that means r is equal to 5 twice. R is equal to 5 twice, okay? So meaning that the roots are equal. R1 is equal to R2. That's what this means. R1 is equal to R2. So it means that the solution to this equation y now is going to be equal to, open brackets, C1x, okay, plus C2 into exponential, we got 5. So exponential 5x is the answer to that question. Let me make this clear. So that is supposed to be C1, okay? So C1x plus C2 exponential 5x. That is the solution for when you have roots that are equal. Okay, so that leads us to something like this. Now, the equation here, we can write it as d squared minus 4d plus 13, okay? All y equal to 0. Remember, y is common here. You see that? So the characteristic equation now is going to be r squared minus 4r plus 13 equal to 0. Now, but I look at this equation and I discovered that we cannot factorize this. We can't factorize this. That means there are no two values that will multiply to give 13 and will add to give minus 4. There are no two values at all. And the only two values I know can multiply to give 13 is 1 times 13. No other two values. And there is no way 1 and 13 will add to give minus 4. So in this case now, we have to use another method to go about this, which is basically the formula method, which is minus b plus or minus square root of b squared, okay, minus 4ac all over 2a, okay? So in this case now, my a is 1, the coefficient of r squared is 1, my b is minus 4, okay, and my c is 13. So if we do that here, this is going to be minus, your b is minus 4, okay, so plus or minus, then we have square root of b squared, which is minus 4 squared, then minus 4 times a. What is a? Your a is 1. What is c? Your c is 13, so times 13, okay? Let me write that here, 13 all over 2a, which is 2 times 1. So that will give us 4 plus or minus square root of 4 squared is 16, minus 4 times 1 minus 13. Okay, minus 4 times 13 is going to give us minus 52. So we have minus 52 there, okay, all over 2, okay? Now let us rub off some side, please, as we continue. Okay, now this is good. So that now continues to give us 4 plus or minus square root of 16 minus 52 is going to give us minus 48. Minus 48 all over 2. Let's see. I think minus 48 can still be broken down. Minus 48 is the same thing as it's going to give us 4 plus or minus 48 is 12 times 4, but that's not enough. I think let's say 16 times 3 works here. So we can say 16 times minus 3 all over 2. So that gives us 4 plus or minus, square root of 16 is 4. So 4 root minus 3 all over 2, okay? And since 2 can divide through, we are going to get 2 plus or minus 2 root minus 3, okay? That's beautiful. Minus 3, which we can now write as 2 plus or minus 2i root 3. Remember, it's a complex number. Why? Because it's a square root of a negative number. Once you see a square root of a negative number, you know you are dealing with complex numbers. Okay, so at this point now, let's rub off. So we can say that our R1 now is equal to 2 plus 2i root 3. Okay, and our R2 is equal to 2 minus 2i root 3. It is obvious here that our a, small a, is equal to 2 and our b is equal to 1. Remember, whenever the roots are complex, the solution to the equation now becomes a, okay, cos a x plus b, where capital A and capital B are constants, plus let's say ib, okay, sine bx. So if we substitute the values for p now, our final answer is going to be a cos 2x, sorry, our b is 2, not then plus ib sine 2x. Thank you very much. Watch out for the next video to see more examples on this. Have a nice day.